of transformations. In this video we look at translations. A translation is a movement either to the left or the right in the x direction. So let's say we start off with this graph here. I can move this graph to the right or to the left. That's called a translation. Or I can move this graph up or down in the y direction. So I can move it up or down. So to describe a translation, you need to specify which direction you're going to move your graph. So is it in the positive x direction this way, or is it in the negative x direction this way? Are you going to move it in the positive y direction or the negative y direction? And how many units are you going to move the graph by? For example, 2 units to the right, or 1 unit to the left, or 5 units down, that kind of thing. The graph of y equals x squared plus 5x plus 6 is just a standard U-shaped graph. I'm going to apply a translation of 3 units in the positive x direction. So the whole graph moves to the right by 3 units. And we'll have a look at what happens to the graph, so looking at the sketch, and what happens to the equation once you've done the movement. So if you've moved the graph 3 units to the right, it should have a new equation. What will the new equation be? This is the graph of y equals x squared plus 5x plus 6. I've marked 2 points on here. No reason for picking these 2 points. We're just going to have a look at what happens to the coordinates of points on the curve after doing the translation. Okay, so we've got this. So moving the graph 3 units in this direction will mean the whole curve will shift to the right by 3 units, including points A and B, and then we will have this graph. And just going back, you can see the x coordinate for A is -4. If it moves to the right by 3 units, it ends up at an x coordinate of -1. There. Once you've done a change of some sort, so you've applied a transformation to a graph, the new points shouldn't be labelled A and B again. They are different points now. So this is A dash, this is B dash, the new points. B was at -1, 2. It moves 3 units to the right, so it ends up here, which is 2, 2. When you move a graph to the right, in the equation, so in this equation here, you're going to replace the x. So every instance of x, you're going to replace it with x -3. I know that seems unusual, but that's correct. If you're moving to the right by a number of units, you subtract here. So in the equation, I've got y is equal to, I'm going to replace the x here with brackets x -3, so I've got this. There was a square there, I need to put that back here on the outside of the brackets, plus 5. Again, there's another instance of x that has to be replaced with brackets x -3 there, so I've done that, and then there's a plus 6. This is the new equation of the curve after the translation of 3 units to the right. And you can show that if you expand the brackets and simplify, this becomes y is equal to x squared minus x. But the key thing to remember here is you're replacing x in the original equation with x -3. So here and here. Starting with the same curve again, this time I'm going to apply a translation of 1 unit to the left, so a 1 unit in the negative x direction. Okay, so moving this graph to the left by 1 unit, so point A should end up at -5, 2, and B should end up at -2, 2. So here we are. As you can see, the y coordinates are still the same. If you move a graph in the x direction, the y coordinates do not change. So what's the new equation of the curve then? I'm going to replace x with brackets x plus 1. So if you move to the left by 1 unit, you replace x with x plus 1 here. So the equation becomes y is equal to x plus 1 squared plus 5 times x plus 1 plus 6. So what I've done here is replace the x here with x plus 1, replace the x here with x plus 1. I could have used function notation for all of this. The same thing happens if I'm moving the graph 3 units to the right, replace x with x minus 3. So the x here, here, and here, I've replaced all of them with x minus 3, as you can see there. And I can do the same with the translation in the negative x direction. F of x plus 1 is equal to x plus 1 squared plus 5 x plus 1 plus 6. Okay, so if f of x becomes f of x minus 2, what transformation has been applied? And we can clearly see that x has been replaced with x minus 2, which means it's a translation in the positive x direction by 2 units. And in this here, x has been replaced with x plus 5. So this is a translation in the negative x direction by 5 units. Okay, starting with the same curve again, I'm going to apply a translation of 1 unit in the positive y direction. I'll start with the y is equal to notation, like I did before. This is quite easy. If you're moving up by 1 unit, so plus 1 unit in the positive y direction, then y is equal to x squared plus 5x plus 6. So that's the original equation there. You just add 1 to it, and then you can simplify this. That gives you 7. For a translation of 3 units in the negative y direction, start with the original equation of the curve there and subtract 3. Then again you can simplify this. 6 minus 3, you can put plus 3 there. So translations in the y direction are easy. Okay, so starting with y is equal to f of x, so using function notation here, if I had y is equal to f plus 1, that just means it's a translation of 1 unit in the positive y direction. And if I had y is equal to f of x minus 3, then that minus 3 tells you it's a translation of 3 units in the negative y direction. Okay, so just to summarize the function notation, let's have a look at the x direction again. If x changes like this, x becomes x plus something or x minus something, then that's a translation in the x direction. If you find you've got the same function again, but you're either adding something or subtracting something, that's a translation in the y direction.